Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will discuss about an issue related to the allocation of frames and which is known as thrashing. What is thrashing, and we will know the cause behind thrashing and how thrashing depends on the degree of multiprogramming and how it is resolved with the local replacement algorithm and the working set strategy with a locality set model. If the number of allocation of frames or the enough number of frames that is allocated to a lower priority process falls below a certain minimum number of requirement of frames by the architecture, then the execution of the process should be suspended. And the frames that is allocated to it should be freed after the pages should be swapped out from that particular memory. So when these frames are allocated and then again swap in and swap out, then it is done by the paging devices. Now suppose for an example, a process is not having enough frames to accommodate all the pages that it requires. So if any free frame is available, then it should be given and allocated to that process. Now if the process are not having any free available frame, then it should replace some pages of some other process. Now, if all the pages that are remaining are currently active in use, so the process is trying to replace a page that is active in use and need to brought back into the memory immediately. So thus, it is actively used pages replaces. And these pages will be brought back to immediately. After then, it will replace again, which will need to be brought back again immediately. And this process will continue. Now the process is doing nothing other than the high paging activity and not executing the process at will. This is the process, or this is the scenario which is called thrashing, when a process is involved with high paging activities without executing the process. Now it can be caused by many different system performances, and it is generally concerned with the degree of multiprogramming. Suppose that a monitor system uses that a CPU utilization is very low. So thus it will increase the degree of multiprogramming and a new process will enter a system. So thus the CPU utilization will increase. Now if the process page that is newly entered has moved into some new directions and requires some other pages, so it will try to use a replace page or it will try to use the available frames. Now, if global replacement policy is taken, then the process will replace pages regardless of having know that which page is belong to which process. Now, it will thrash from other pages processes also. So that becomes that other process is having require some more pages, so it will again fetch some pages from the other process, and that process will also fetch some pages from other process. This paging activity requires to wait up into the swapping of swap out time, and this is done by the paging devices. So all the process will queue up in the paging devices while emptying the ready queue. Now this scenario causes thrashing, that is increasing the degree of multiprogramming. They are increasing new processes into it, so the CPU utilization drop will seen by the operating system, and they will see the CPU utilization low, so it will increase again the degree of multiprogramming. When another new process enters the system, it will try to fetch and replace the pages from the processes which are already waiting in the device queue for the paging. So the new process will be added to the paging device too. Another time the CPU utilization becomes low, then again the increase of degree of programming, then the degree of multiprogramming makes the CPU utilization even low. Thus if this can continue, then the final degree of programming, the system throughput plunges and it will reach the zero. Until and unless all paging devices queue is become full and the queue becomes serviced by the paging devices to swap in and swap out the replacement. So in this way we can see that thrashing occurs if we can increase the degree of multiprogramming beyond the given limit. So when we are increasing this degree of multiprogramming and plotting in a graph with the CPU utilization in the y-axis and the degree of multiprogramming in the x-axis. So you can see that the CPU utilization will increase slowly with the degree of multiprogramming until it reaches a maximum level. After that, if we increase the degree of multiprogramming, the CPU utilization will drop eventually, and at the last it will plunges and reaches the zero of the CPU utilization. So here we can see that if we increase the degree of multiprogramming beyond a certain level, then it will obviously cause thrashing, because all the processes will be used and subsequently spend their time while paging and queuing up for the paging device, waiting for swapping and swap out, rather than actually executing the process itself. So one solution to address this problem is using the local page replacement algorithm. If we use the local page replacement, then when the operating system sees that a process is already thrashing, it will restrict the process, fetches the pages from the other process to involve the other process in the thrashing. In this way, the thrashing can be prevented, but not its entirety. Because the process is now having a higher rate of memory access time and higher rate of swap time, so it will then add it up in the queue, that making the longer the effective access time. So the processes which are not also thrashing will give this effective access time increment as the cause of the thrashing. So here we use other various ways to solve this problem. One way is to use a walking set strategy that is based on the assumption of the locality set of model. We know that a process moves from locality to locality for a assumption, whereas a locality is a set of actively used pages together. A program can have several more localities which may overlap also. Now, for example, if we take a program which is making a function call, so it will have localities for the instruction, for the local variables, and some subset of the global variables. Now, when the function calls is returned, so the locality of that particular instruction and local variables are not needed, so the active pages are then can be replaced with some other pages, which was the current active page for that locality, but it is not used in this now locality that the function call has returned. So this may be used later. Now we can see that the locality set model is described by the program and data structure, and it states that a program should perform its basic memory reference structure always. Now, if a program tries to access any pages rather in a random pattern than in a patterned section, then caches will be of no use. Now, if the current locality is given with enough frames, then it can continue with the program execution. Suppose that a current locality is not having a frame, so it will page fault. Now, if all the pages that is needed for that current locality is given to it, so it will not page fault until it moves to the next new locality. When it enters the new locality, if that particular time, if the current locality, the allocation of frames are not enough for that particular process, then the thrashing will occur, as that allocation cannot be continued the execution part of that process. So the locality should be always given an enough number of frames to hold the pages that will be needed in that particular locality execution. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.